Welcome everyone. This is Chris Clark, one of your hosts for the VAS webinar, Is Your Soil in Need of a Health Check? Many of you have known us as AgSource Laboratories, and we're definitely excited that we have joined forces with our sister company to now operate under the name VAS. Together with their agricultural software expertise like DairyComp, and our extensive amounts of laboratory data, we have much to provide our valued clients now and into the future. First off, we want to thank you for joining us. We definitely know that your time is valuable and want you to know that our experts have spent a lot of time collaborating together on this webinar to hit a broad list of attendees here today. So once again, I'm Chris Clark. I'm a certified crop advisor in Wisconsin, and I'm joined by Dr. Jim Friedrichs, a PhD for VAS in soil and agronomy. As you listen, you'll use the question and answer box on your screen to submit any questions you have during the presentation. And then also a note, we will continue with a live Q&A after the webinar with the assistance of Nicole and Kate as moderators on the questions. Dr. Friedrichs of Iowa has led our team of research and development for 3 different VAS soil health assessment packages. He also developed the report, and he keeps tabs on future soil health metrics in the research community. While myself, I'm going to share conversations that I've had with farmers and other crop consultants, fertilizer dealers, and consumers about the role that soil health practices play in agriculture, and overall getting back to a healthier soil that's willing to do more work for you in the field each season. A reminder that this presentation can be used for CCA continuing ed credits. What you will do is report 1 soil and water CEU. You'll have to know the information that's kind of on the screen right now. The presentation title, our location we're going to make as Madison, Wisconsin, which is the headquarters for our company. Our sponsoring organization is VAS AgSource Laboratories. Today's date, and then the area is 1 CEU in soil and water. Please make sure that in order to get the credits that you take the survey that will pop up when you exit Zoom. And we want everyone to also participate in that survey afterward. After the webinar, attendees will also get an email that will have some references that will be talked about in the webinar as well. And then feel free to print and share that with anyone that couldn't attend today. And then again, a note, we will be recording the webinar and we'll share the link afterward as well. I believe this about covers our housekeeping items, and most of us have joined us. It is now time for the Soil Health VAS webinar. Is your soil in need of a health check? Much like your annual doctor exam, a doctor may collect your blood, your urine, or even a stool sample. You may tell your doctor, I eat healthy and I exercise, but it's your laboratory tests that tell the real story. There's no lying that truth is in the tests, and the same is true for your soil. There's definitely a range of parameters that make up quality soil, and soil health testing is an objective measurement that you can benchmark improvements that are being made. You cannot manage what you do not measure. Let's learn why now is the time to start capturing soil health metrics on your farm. All over the country, some soils are worn out, depleted, exhausted, almost dead. But there is comfort that soils possess the possibilities to be restored to high productive power, provided you do a few simple things. You may be thinking, Chris, is it really that bad? I dove into some research a report from the USDA Land Degradation Overview, and I found some really eye-opening information. The productivity of some lands worldwide has declined by 50% due to soil erosion and desertification. The estimated annual cost of erosion from agriculture in the U.S. is about $44 billion per year, or about $100 per acre. Just take note that some of your best topsoil has probably already washed away from your field. Globally, the annual loss of 75 billion tons of soil in the world is about 400 billion per year, where that costs about $70 per person. And that's per person, not per farmer. But what about yield? A Schumacher study showed that yield reductions of 20 to 40% has been measured for row crops in Midwestern states. Soil compaction is also a worldwide problem, causing yield reductions of 25 to 50% in some regions of Europe and North America. And on-farm losses through compaction in the U.S. has been estimated at $1.2 billion per year. So here's a really good visual of how soil health is being lost in your fields. After years of crop farming, we know that many of your fields have been farmed for 50 years or more. Active erosion is present, and each year higher and higher yielding crops leave behind less crop residue, which serves as food for the soil life. The soil aggregates begin to break down, and soil organic matter decreases. Thus, there's an opportunity for more erosion during the next wind and water event. The soil easily compacts due to the lack of soil aggregates, and a soil crust will form. That means that also more soil organic matter can be lost. Less water is able to infiltrate and stay inside of your field, and there's more surface runoff, decreasing the diversity of soil life in that field, which then reduces the amount of soil nutrients that are cycled for the plants, like the nitrogen cycle or phosphorus cycle. This then decreases your yield, and crops begin to lack proper nutrients, which decreases the quality of feed or food for livestock and humans. This is what's happening in your fields right now. So if you don't pay attention to soil health, it's time to start thinking about it. On the left in this diagram is a picture of a healthy soil with really good water infiltration. There's about 50% water space and 50% air space. This is a really great place to grow crops. It's easy for roots to go down and seek nutrients in the soil. On the right side, this is an unhealthy soil that has had impacts of erosion and compaction and a surface crust. This prevents water infiltration, thus causing erosion on the surface of the soil. So next, take a look at these soils. We've got letters A, B, C, and D, and this is going to be our next poll question. Which kind of soil do you want to grow your crops in? Okay, it looks like a majority of people chose letter A, with letter B and D following pretty close behind. Your answer should be, it's a trick question. I don't know yet because I haven't done a soil health test yet. So keep paying attention to the presentation and remember that a soil's looks may be deceiving. The truth is found inside soil health tests. So what kind of soil do you want? Healthy soils are going to be resilient through many different types of growing seasons. You want a soil that's going to be able to have higher water infiltration, so after a drenching rain, the water doesn't pond or leave the field. It's a soil that can support high quality crops that you're going to feed your dairy animals, livestock, or people. It's a soil that has a lack of erosion present. It provides an excellent seed bed, which provides for an easy root growth and even emergence across the field. It has healthy, vigorous plants, which are better able to resist insect and disease attacks during the growing season. You're going to have a higher yield year after year because the soil is going to be doing more nutrient cycling for you. There's going to be a lower weed pressure present, and your fields are going to take less horsepower to till up. Who wouldn't want these things on your farm? And over time, these characteristics have decreased. And how do you know if they're decreasing? Is by doing an annual soil health test. So soil health is a very real thing. Have you ever worked up one of your fields and that earthy smell just fills your tractor cab? That is soil health. Have you ever seen fields that always have abundant birds, nature, or beneficial insects that are found in them? That too is soil health. Have you ever dug a hole in a field or a garden and saw earthworm channels? That is soil health. Well, okay, officially they like to say that soil health is a combination of three things: the chemical, the physical, and the biological portions of the soil. As an agronomist or a crop consultant, we've been trained and we're very good at feeding our crop. We can produce very high yielding corn and soybeans, but we aren't really paying attention to what the soil needs to be fed. And that's what a soil health test is going to help you do, is determine how to feed your soil. So soil health, it's actually difficult to do any in-field tests for soil health metrics. Thus, regular lab testing to capture soil health metrics is going to be key to your success with any degrading soils. Across our testing laboratories, we're very impressed with how well our fields are being managed for the chemical portion of soil health. That means that farmers and crop consultants, you're keeping track of your current pH, phosphorus, potassium, and organic matter levels. And an increasing number of people are also testing for calcium and magnesium. Farmers are able to maintain and build their nutrient levels, which also helps soil health. So our next poll question is, do you test for soil health? Yes or no? And the results of our poll looks like we've got 54% that are replying yes, that they test for soil health. And we have 45% that are saying no, they do not yet test for soil health. So managing for your soil health means that you're going to capture some of that biological metrics that are out there. Some of the ones that we are able to do at VAS and include in our 3 different packages is the CO2 microbial respiration. Some people have heard of this as the Solvita test kit. At our laboratory, we will take the soil and give it the prime conditions by putting it in an incubator for 24 hours at an ideal temperature, and the microbes come back to action and they start breaking down and releasing CO2. And we put that on a machine and it measures the specific amount of CO2 given off. Another one is the carbon to nitrogen ratio. This is really important because carbon is the food source for all of the soil life. We don't really care about carbon for the crop, but this is one we have to start paying attention to for the soil so that it's got what it needs to. There's a water-soluble analysis which measures the levels of nutrients that are most available to soil life and to plants. One of my favorites is mineralizable nitrogen because this is the ability of organic matter to supply nitrogen to the soil and soil life. And you can't really get that one unless you're doing a soil health test. There's a water saturation percent, which gives you a measure of how much water your soil can hold. And then there is also the Haney test that we conduct at our lab too. So let's take a closer look at the soil health report and these metrics. Customers really do love our soil health report. It's really easy to follow. The top section has the most recent chemical tests. We like to say have the chemical test or your soil test done on the same sample that you're going to be doing your soil health tests on. So that's kind of the left portion of this report that you can see. And then your eyes move toward the green section. This has the soil health tests that VAS includes in our soil health metrics. This includes the water-soluble results for 8 different elements, the Haney test, and the soil health score. The report has 20 total different soil health indicators. And just like a chemical soil test, the test is going to reveal if your soil is falling in ideal ranges or not. We do have a guide that will help you review these new numbers and what is ideal, and we'll make sure to send you that guide in the follow-up email to everyone on this webinar today. So what do the results mean? So here are kind of what the ideal ranges are. So for a soil health score, it ranges from 1 to 50, and it's calculated by combining 5 different measures. Most agricultural fields that will have a number of 15 is a healthy soil. But don't stop there, because we do have some soils that you can have as an agricultural number of 20. A CO2 respiration, the most common range is 60 to 150 is considered healthy. And if you're over 150, that's very good. A carbon to nitrogen ratio of 10 to 15 reveals an ideal level for normal soil health. Soil health metrics will continue to evolve, and my coworker, Dr. Jim Friedrichs, is working to determine additional tests as researchers continue to refine soil health. We know that there's definitely a need for more research. And this does continue across the globe. One note is that soil health is specific to individual fields' histories. So it may be specific to soil type, your environmental conditions that you have in your unique state or county, farm management choices as far as your crop rotation or tillage. So you have to also think back to your native soil. So before it was even farmed. For example, I'm coming to you from northeastern Wisconsin, closer to Green Bay, and this land was originally forest land. While my coworker Jim is in Iowa, his land was a native prairie. The soil health metrics for these two soils will never be equal. So that's something to keep note of too across your farm. Overall, soil health is a long-term investment to your soil, and in many areas it is known that improvements to degraded soils are needed across the globe. If you love soil as much as we do at VAS, you know that you can take a role in rebuilding soil health on the lands that we can impact. Organic matter is one foundation for a high-quality soil. Organic matter, again, is the carbon. And the carbon is that food source and the home for a lot of the soil life. Organic matter has a huge influence on soil's many different properties. It has an influence on all three of the soil health characteristics, the biological, the chemical, and the physical. So it is known that organic matter can control over 90% of a soil's functions. And organic matter consists of three different parts. We have living organisms and things that you can see with your naked eye or with a microscope. We have fresh residues, so if you're going out there, you're like, yep, this is still a bit of a corn stalk or a piece of a soybean. And then we have well decomposed or dead. So you really can't tell what it is, and it is very close to becoming that humus or your next best topsoil. Organic matter is the main driver in water availability and retention. So it is known that as organic matter increases 1%, water retention, that is able to contain 1 acre inch or 10% of a soil's water holding capacity. Organic matter does help with water infiltration and keeping it in your field in between rain events rather than having it run off your field like we showed before. If it's a degraded soil, a crust will form and then it ends up becoming surface water that leaves the field and your crops won't be able to get it. A Michigan study was able to demonstrate that the potential crop yield increases about 12% for every 1% organic matter in the soil. And then additionally in Maryland, researchers saw an increase in approximately 80 bushels of corn when they were able to increase organic matter in a very degraded situation of 0.8 organic matter to 2%. So how much organic matter is good? At the laboratories, we also know that organic matter has been trending down for some time. Organic matter has fallen from 5 to 6% to less than 3% on some productive agricultural lands today. It's really easy to do like we saw earlier in that diagram because each time that your soil is tilled up, it mixes in oxygen and then some of the organic matter is accelerated to be broken down and lost. 60 years of use, so we have a study here listed on the right, and the changes to a field after 60 years of farming. The takeaway from that is that the hilltops and the back slopes of the landscapes have been eroded and is known to have thinner topsoil with less organic matter. And then the lower areas that are receiving that eroded soil have deeper topsoil with higher amounts of soil organic matter. And we know that in general, there's a couple of guidelines that a 2% organic matter on a sandy soil is really good, and it could be difficult to reach, but yet 2% organic matter in a clay soil means that it's greatly depleted. So once again, you have to know a little bit about your soil type and where it started with soil organic matter. Some have been able to achieve 0.1% of an increase in organic matter, but that's in a very degraded situation where the soil was able to bounce back quite quickly with some management practices. But you can expect this to be much slower on other soil types. So our takeaway on organic matter is, once again, it is the food source for soil life. So we have to start paying a little bit more attention to that when we're talking about soil health. And your fields or parts of fields that you can identify, perhaps with grid soil sampling, with the lowest organic matter will benefit the most from practices that will build up organic matter. And we'll talk about some of those things yet in this webinar. And then again, my favorite, or one that I've seen some really good responses on is mineralizable nitrogen. And that is the one that is taking into account that free nitrogen that comes from organic matter. And it is so often released right when your crop needs it. And perhaps maybe when you can't get out there and do any applications anymore. So this is really how the soil is doing more work for you. And you're not going to see this on a chemical test. You have to do a soil health test in order to get this metric. So for example, 10 to 30 pounds of nitrogen can be released per 1% of organic matter. So that's kind of an estimate that you would get. But by doing the actual mineralizable test in the laboratory, we'll be able to give you specifically what your soil is able to provide. So next, Dr. Jim Friedrichs is going to take you on a tour of some research with farm soil health metrics. As he's talking you through the research and the results, I want you to imagine different parts of your farm or your client's fields where you could start tracking soil health metrics for. So think about fields that maybe aren't reaching the same yields that they used to be able to. Maybe you have newly purchased land that you're not really sure about the field history. And think about how he explains how they did their research project and got the most out of doing soil health metrics.
Thank you, Chris. Again, I'm Jim Friedrichs. I enjoyed being here with you today. I'm looking forward to talking a little bit about soil health and the research that we've done at VAS with our partnership with Practical Farmers of Iowa. We started doing soil health analyses in 2016, and over the period of time, we've seen some variability. And one of the things we've seen quite a bit is that there is some variability depending on when you take your soil sample. So one of the questions we will address is, when is the best time to take a sample? And then how can you best sample your farm to capture the soil health values that you're looking for? Where should you sample? Where can you identify? And how do you compare that? How do you use that in that information going forward? The research project that I'm going to be talking about specifically looks at the seasonal variability and some land use impacts on the soil health qualities, and pretty definitive or pretty clear differences that we can identify from that. Some of those metrics show up in the standard soil tests of organic matter, P&K and pH values in the field, but some show up quite clearly in the soil health score, the respiration rate, and the measurements of nitrogen, either the C-to-N ratio or the mineralizable nitrogen. So we'll look at those and see how season and management impact those characteristics of soil. First of all, when is the best time to collect that soil health sample? As I said, the variability we've seen over the years is that month to month there is some variability, and the best times is in the active growing season. We generally would say that sampling right before planting through right after harvest is the right time. You want to make sure that you don't sample after the soil temperatures have dropped below 32 degrees Fahrenheit, because that freezing does change the characteristics of the organic matter and releasing the easily mineralizable carbon sources into the soil. And so that does influence the values that we're measuring. How do you collect a sample? It's just like a normal soil health test. The soil sample, a 6-inch core would be adequate. You want to make sure you get a representative number of cores per sample, and you want to make sure that the area you're sampling is representative of the field that you're looking at. I wouldn't advocate using a grid sample pattern for soil health because of just the intensity of that, and the cost involved is not necessary. but make sure that your representative area is not too large. 20 to 30 acres probably is adequate, and use the concept of zone to pick an area that you want to represent and collect your samples from that larger area. An interesting way to sample is to, especially if this is your first time taking a soil health test, is to sample your agricultural field, your field that's been cultivated and you're actively cultivating now, and compare that to an adjacent field or an adjacent area that's not been cultivated. Could be a fence row, could be a pasture across the fence line, anything that you might consider a more native situation that's been under year-round cover. And that'll give you a way of assessing the impact of cultivation on the soil in adjacent soil situations. Starting in 2018, I was able to partner with Practical Farmers of Iowa to do some soil health management or soil health assessments on some land that was managed by a farmer who's raising grass-fed beef in west central Iowa. This is a situation where a lot of the farm is under CRP, and part of that CRP has been grazed, some and has not been grazed. And then there's also the pasture up by the main part of the farm, the farmstead. The pasture is right behind the barn. It's been in pasture for years and years, and it's historically been the location where a lot of manure has been spread. So it has different characteristics than any other part of the farm. And then down in the valley below the farmstead, there is a portion of the farm that is row cropped, and it has been in corn and soybeans for the 3 years that we've been looking at this farm. And I believe part of it, the ungrazed CRP, which is adjacent to that row crop area, was also cropped in the past, but it's now under CRP grass. We went out 4 times a year to sample right early in the season at these stages of corn growth. The first crop was soybeans, but this is V4 for corn in the area, tasseling, after black layer, and then post-harvest. And as I said, these are the 4 areas that we did sample for comparison. Excuse me. Looking at the results of the soil tests, on the left, standard soil test results. The row crop area has been in row crops for at least 20 years, if not longer. It has a low pH, low organic matter. Phosphorus and potassium are very low, which even in the 2 years after this represents the first year, but even in the subsequent years, it's still low. And you can see the CEC is fairly low as well. The pasture would be the ideal or the best soil on this farm. It has a higher pH, much higher organic matter at almost 3.9%. And phosphorus and potassium reflect the years of application of organic manure to that soil. And you can see that that has maintained a high CEC and maintained a low bulk density of that. The CRP ground, both the grazed and ungrazed, are intermediate between those two, and both of them have depleted phosphorus, but the potassium levels are a little bit higher than the crop ground. On the right, you can see the values from the soil health assessment of those same locations. These are averaged over the season, all 4 of those samples. And you can see, not surprising, the row crop has the lowest value, soil health 11, and the pasture has the highest soil health value of 20. As you think back what Chris said about the ranges, anything be up to 15 and above is a good soil health score. And so you can see that 10, 11 is right at the bottom of what we consider good, but 20 is considered in that very good range. So managing the soil application of manure over a long period of time has kept that pasture in a healthy state. Looking at the respiration rates of these soils, again, these samples are taken from the field, they're taken to the laboratory and treated in the lab. So it's a laboratory assessment of what's going on in the field. But here you can see that the CO2 that's evolved from that respiration is quite dramatically different between the row crop and the pasture. Almost double in the pasture than it is in the row crop. And in the areas that are under grass, there's a good amount of respiration taking place. Again, these are averaged over the season and statistically different between the row crop and the other areas as well. The respiration rates are measured in a vessel. As I said, we take the sample out of the field, dry it, and grind it. And then we take a portion of that soil and rehydrate it in a vessel, adding a volumetric amount of water to it, cap it, and incubate it for 24 hours. And then we measure the amount of carbon dioxide in the evolved gas by purging that vessel and measuring the CO2 concentration in that vessel. So it's a good evaluation of what's being evolved, and it's a very quick assessment. We can run a sample every couple minutes with this setup. For water-soluble carbon and nitrogen, the values tend to reflect the same pattern as we saw with the respiration and the soil health. Lower in the row crops and higher in the pasture, and the CRP, at least the grazed part of the CRP ground was significantly higher than the row crop. The ungrazed CRP has a lower water-soluble carbon. Again, I think this was area that was cropped in the past, and so it's not quite as vigorous growth as the grazed CRP, which is higher up on the elevation. But the pasture is significantly higher, both in carbon and in water-soluble nitrogen, because of the vigorous growth that's on there, as well as the management, the application of manure that's taken place over a number of years. Both of those measurements are performed on a water extraction of the sample. So we read them in this instrument at the same time. So it's an accurate evaluation of the sample of that extract at the same time. And from that, we get the ratio of water-soluble carbon to nitrogen, which is a useful value, but notice that they all look about the same. Remember that the carbon and nitrogen ratio, carbon and nitrogen extractions, the pasture was much higher than the row crop, but the ratio of those two ends up being about the same. So just using the seed-end ratio to evaluate the health of your field is not really going to tell you a whole lot of information, because it normalizes everything in perspective to either the carbon or the nitrogen. We did see, however, that as we looked at the samples month by month, that there was some variability in the seed-end ratio going through the season. And it tended to increase over the season, although July was high. May was low, and that makes sense. There's a lot of nitrogen in the soil released from early mineralization of organic matter or application of fertilizer to the row crop area. And so there's higher nitrogen. That's used up in July, and then again in November it's released. What we do see in this change over time, if we look at that, of all the characters of these three characteristics over time, the soluble carbon, the soluble nitrogen, and the ratio of each of the management areas month by month. And so we see that in the center of this graph is the water-soluble carbon. That tends to increase as you go through the season, and particularly in the pasture areas, you can see that the water-soluble carbon is higher. But and then the nitrogen values tend to be lower in the end of the season, just because of the utilization of nitrogen and the decline of growth. What happened was these samples were taken in July, in August, September, and November. And the sample that was taken in November, post-harvest, was actually taken after the first frost. When we were sampling some of these fields, we actually had to push through some frost in order to collect the sample. And so my assumption is that the water-soluble carbon on those samples was higher because of the release from the decaying organic material that was in that sample. Post-harvest, senescence of roots and the release of the sugars and carbon sources that are easily consumed by the organism when that sample is brought into the lab, add moisture added back to it and warmed up for a 24-hour period. You get this flush of growth and release of carbon dioxide, and so you have a higher ratio, higher carbon-nitrogen ratio in that last sample than you do in the other samples, particularly September. The mineralizable nitrogen is a value that we calculate from a combination of the respiration rate, the water-soluble carbon and nitrogen, and the extractable nitrogen that's in the soil. And so this is a value. It's not an incubation that you normally would consider, but it is a direct assessment based on these other characteristics and a calculation that's based off of those. From that, then we can see that as you would anticipate, the available nitrogen from these different soils varies across the different management areas, lowest on the row crop and highest on the pasture. Both the CRP graze and the pasture behind the farmstead had a considerable amount of nitrogen that would be released over time to a crop that's growing in that soil. The CRP, the ungrazed CRP, again, it's a less dense stand of vegetation, and that nitrogen is probably utilized more readily, more actively by the crop that's growing there, and there's less turnover, I believe, is what's happening. This measurement of nitrogen is the amount that can be credited to that soil for the crop that's going to be, that either is presently growing there or will be growing there in this growing season. We do calculate a comparable value based for phosphorus, mineralizable phosphorus, which is the phosphorus that would be released from the organic matter that's present in the soil. But it also incorporates the value of some of the extractable phosphorus that's present as well. And so those numbers, I don't show them here, but those numbers are based on both the biological and the chemical evaluation of the soil. If you look again at the overview of these, you can see that the samples were collected June, July, September, November. And so you can see some of the variation in these values. What I'm showing here is just the average of all the values, but you do remember that some of those do change month by month, especially the respiration rate and the seed-end ratio did vary somewhat by month. But not surprisingly, and in summary, the best soil health is pictured here under the pasture. The lowest soil health is under the row crop. And those are the two extremes of management and of inputs into the soil. And so it's not unexpected. It's what we would expect to see. Highest amount of nitrogen available over time would come from the pasture area and the lowest from the row crop area. Here we have another poll question. A lot of management of soil health has to do with plant cover. And so we're interested in knowing whether you plant cover crops in the land that you either manage or actively farm. All right, as we get the results back up here, looks like about 2/3 of our participants today do plant cover crops. That's a good number. 34% have not or do not plant cover crops. Maybe you're not actively farming, but thank you for your input. The number of, the amount of acreage that's planted in cover crops is slowly increasing. Some areas of the country, there's a lot in the eastern seaboard, particularly in Maryland. A lot of the ground is planted in cover crops, and that's a requirement of the nutrient management reduction strategy that they have. Here in Iowa, there is emphasis on planting cover crops, and more, you see more and more of that taking place, but it's still approaching about 4 or 5% of the fields are actually planted to cover. What are some of the things then, besides cover crops, that we can do to maintain or improve soil health and to increase the soil health of a degraded area? And really, it's sticking to the basics. One of the fundamentals of having a healthy soil is to manage the fertility status of that field, of that soil. That you can do through regular soil testing, following the recommendations of the soil test or your nutrient advisor, your nutrient management plan. Maintaining soil pH is one of the big things you can do. The cropland in the research that I showed has a pH of 5.6 or lower, and I think that would benefit just from an application of lime. And higher pH means higher fertility just from phosphorus availability and some other things. So application of the nutrients and managing them, making sure that there's adequate for the crops that are growing there is always important. Keeping your soil covered year-round is also vital. Practical Farmers of Iowa has a saying that says, "Don't farm naked." And what they mean by that is don't leave your soil uncovered. You want to make sure that there's something on the surface of the soil, either residue or a growing crop, year-round to protect the surface, minimize erosion, minimize crusting, and provide some organic material either to the soil or to the roots that are growing in the soil and the organisms that are growing in the soil. Diversity in what organic materials go into the soil is helpful. Monocropping, continuous corn is maybe a high, does generate a lot of organic material, but it's all of the same nature. And so the organisms, there will be certain organisms that flourish in that, but if you can change that quality or the kind of organic material that's added, you'll get different kinds of organisms flourishing because of the variety of organic material that's added. And then, of course, reducing tillage and preventing compaction. Those are things that will allow for better aeration of the soil, water infiltration, and a good habitat for organisms as well as roots in that soil. So ask yourself then, what practices are you following, and are these practices either increasing or decreasing the health of your soil? Things, you can see the list here. Things that increase soil health would be reducing tillage through minimum till or no-till, adding diversity in your crops, either through relay cropping, different crop rotations, adding cover crops, making sure that there's biomass on the field and a cover over the field so that what is growing there on the surface is also reflected in the subsoil or in the soil itself. And a diversity of vegetation will mean a diversity of material in the soil that feeds the microorganisms that are there, which are beneficial. So adding perennial crops such as alfalfa or something or grasses that are there more than one season just to maintain active roots in the soil is a good practice. Manure application, increasing surface residue, and then doing a good job with pest management and weed control, and those practices that provide for a healthy crop will also provide for a healthy soil. Things that decrease soil health would be application, a lot of tillage, going out and just maintaining a black soil because it looks nice may not be the best for the health of that soil long term. So make sure that surfaces are covered when, particularly in the time of year where you get a lot of rain and the intensity of rain. We're seeing now that more and more heavy rainfall events, and so those tend to be more erosive. So make sure that there's an adequate vegetation cover or residue cover on the soil to minimize erosion and minimize compaction, crusting of that. Annual cropping, etc. Fertilizer management is also has a big effect on the health of the soil. Follow prescription, apply what's needed, and don't over apply, but make sure that you apply enough. and make sure that you do a good job with managing the fertility and the quality of the crop that's growing there through pesticide and weed control management. This next slide, I'm going to turn over to Chris. She has a story that she heard and would like to relate to you. So Chris.
Yeah, so I had the opportunity in 2019 to attend the Wisconsin Cover Crop Conference, and the keynote speaker was Rick Clark. He's a farmer in Indiana. And while what he's done isn't for everyone, I just think that it kind of ties together some of the things Jim just talked about, and just getting you in the mindset of here's someone that is taking care of their soil and it's paying him back. So this wasn't a short-term process. This is probably about 8 or 9 years that that he's been working on his 7,000 acres where he's growing corn, soybeans, and wheat. His process was to convert to no-till, and then he's planting green into a living crop of cereal rye. That cereal rye provides a way to maintain some moisture and then prevents weeds, and he is sequestering nutrients in that crop while it grew, and then it becomes available to the cash crop as it then gets broken down and digested by soil life. So through his strategy, he was a numbers guy, and he really got some good stuff put together on his farm for what it was paying him back. So less tillage meant that he burned half of the diesel fuel that he did in 2011 compared to 2018. And then nitrogen fertilizer, he was going from 220 pounds to now only putting on 110. And then his MAP use went down 91.8%, and he stopped applying potash and lime completely. And then chemical costs for 2018 was $18 per acre, and he was ballparking that for this year when I heard him speak in 2019 for about $5 per acre. And if you total all that stuff together for his size of operation at 7,000 acres, that was $632,000 that was staying in his pocket. And the big takeaway from that wasn't listed is he will spend one crop year in his crop rotation called a regen year, where he pretty much works in a crop rotation of a cocktail mix of cover crops. And he's not getting any yield or a cash crop that year, but he's just purely building his soil. So while that's not for everyone and we can't all budget for that, it's just something that I've gone around and talked to different people about, being a crop consultant and stuff, and it is interesting. So one little step here and one little step there can really help your soils on your farms. So overall, we want the farmland to be here for your grandkids to farm. Improving soil health helps you build a resilient soil that's better able to withstand extreme weather, and a soil that's going to do more work for you if you keep it healthy. So we hope that when you get the email of resources that you'll see in there a spot that you can request soil health kits. You'll have in there the form that will describe the 3 different packages and what they cost. It'll have in there a soil bag and some directions about pulling your soil health samples and then where to send them to. And overall, we do thank you for your time, and stay tuned for the live Q&A. If you have questions, remember, add those into the question and answer section on Zoom. So Kate and Nicole will help us with the live Q&A, and Jim and I will be answering those questions. So thank you again.
Thank you, Chris and Jim. We do have a few questions that have came in over the course of the webinar. One of those questions is, what is the difference between soil testing and soil health testing?
I'll answer that. When we talk about soil testing, we're primarily thinking about the chemical measurements. So that'd be pH, phosphorus, potassium, calcium, magnesium, CEC, organic matter. Those are the routine things that a soil testing lab measures. When we talk about soil health testing, that generally involves the biological assessments as well. So that be the carbon to nitrogen, soluble carbon, soluble nitrogen, respiration rates, other water extractable components. We look at nitrate or ammonium, and then we use the Haney extract or the H3A extract, which is an organic acid, which it is a chemical analysis, but it's designed to extract a lower value of nutrients that are more related to what the solubility at the root zone is, and what is availability of those nutrients at the root zone. So it's a different way of assessing chemical availability in the soil.
Thank you, Jim. Another question that came in, how should I prepare a sample for the lab?
Good. I think I can take that one. Jim explained the best time of the year to take it, and you pull that like a regular soil sample, so the same depth, that 6 to 8 inches deep. Fill up your soil bag with about 15 to 20 cores, and then you don't have to refrigerate it or freeze it or anything like that, but I just have people pay particular attention that you don't leave it in a vehicle where it gets too hot, or at a very high temperature. That would be bad. That would kill off some of the microbes that we do want to test for. And then making sure that you get it to the lab in a timely fashion. It's not like you have to rush it there, but sending it to the lab within a timely fashion is good.
Thank you, Chris. We had another question come in. Do you have any information or tests on different row cropping practices? Till versus no-till, different form of nitrogen, etc.?
We've not done that research. There are other organizations that have good resources. The Soil Health Partnership is part of the Corn Growers Association, and they've released some information that's a good resource for practical evaluations of practices like that. The Soil Health Institute has some information. They have a good library of information if you want to do some research, but they're more focused on testing methods and a large-scale evaluation of soil health. So, but they do have a very good library. So either one of those would be good resources. We don't have that information at this time, but we're building our pool of information, and hopefully we can do some research along those lines as well.
Thank you, Jim. And our last question we have so far, unless anyone else submits one, is how long does it take to get a soil health result back?
Yeah, if you take your soil health sample and get it to the lab early in the week so that it's not arriving like on a Friday, you can expect to have your results back in 5 working days. So we do a really good job with processing the samples, and it is longer than a normal chemical soil test, which we can get done in 48 hours. So yeah, about 5 days.
Thank you, Chris. That was our last question.
Thank you all.
Thanks, everyone.